कुछ बेसिक क्वेश्चन से स्टार्ट करते हैं, देन विल गो फर्दर, आगे जाएंगे. So the common and general question is always, so what is different between IaaS, PaaS and SaaS? So IaaS is called infrastructure as a service and PaaS is called platform as a service. SaaS is called software as a service. So in IaaS, you manage OS, runtime apps, everything. Now in PaaS, Azure manage OS and you manage apps. Now in software as a service, everything managed by the provider. You just use the software. Now we are having a very fast look to this. So for example, VM is IaaS, app service is PaaS, whereas Office 365 is SaaS. So what is Azure Resource Manager, ARM? Now Azure Resource Manager is management layer of Azure used to deploy and manage resources. So Azure Resource Manager is the management layer of Azure used to deploy and manage resources. So deploy resources using templates, manage resources through resource groups, role-based access control, tagging support. Now to create the resources, Azure provides you many interfaces. You can use Azure Portal, you can use Azure REST API, you can use PowerShell, so you can use Bastion, you can also use third-party services. So many things are there. But all these interfaces at the end makes a request to ARM, so ARM, Azure Resource Manager. And then Azure Resource Manager will create the resources for you. Now, what are the capabilities of ARM? So it will help you to deploy the resources from various interfaces. Beside that, you can also deploy the resources using templates. If you create one VM, while creating that one VM, we can save it as in template. And once you save it as in template, so we can use that template to create another, we can say, resource. So manage resources through resource groups. Okay. So it will help you to create logical grouping of the resources so that you can manage them together or logically separated. So it will also follow the RBAC, role-based access control. And it also supports tagging support where you can tag the resources so that the searching or again internal logical grouping of your resources will become easy. Now, what is different between the region and the availability zone? So region is basically a geographical location. Availability zone separate data centers within the region. The availability zone reside inside the region. Region is larger perspective where one region can have at least 3 availability zones of that. So region will help you to group the geographical area, whereas availability zones will help you to group the data centers within that region. Now, for example, Central India will have the zone 1, zone 2, zone 3. Improves latency, improves availability. So your region will help to improve the latency. If your customers are located in Canada, so you can use the Canada Central region. And availability zone improves the availability. If one zone get down, so your services will be running on another zone. What is the purpose of resource groups? So resource group organize related resources so they can deploy together, manage together, delete it together, monitor together. The resource groups organize related resources so they can be deployed together, managed together, deleted together, and monitored together. Now here, so monitor together. For example, we can create the resource group as per your requirement. We can create a resource group for e-commerce app, application wise or team wise or your office wise. You can create the resource groups. So which contain multiple resources like web app, SQL, database, storage, accounts. Now your application users are mostly in Europe, but your database in Asia, the application is slow. So what would you do? Now these are the scenario-based questions. So as an experienced developer, so company will always ask you. So scenario-based questions of that. As an experienced developer, so companies will ask you so scenario-based questions of that. Now this is a scenario-based. So your users are mostly from Europe and your database is in Asia. The application is slow. What you do to deploy resources closer to users? Possible solution: move database to European region. One option. Simplest option. Another option: use geo-replication. So geo-replication will help you to replicate data across multiple regions. Or you can use the CDN, so Azure CDN, Content Delivery Network. So that will cache the data and it will improve the speed. Now, the first preferred option is always move database to a user-specific region. But if your users are scattered across multiple regions, then what we can do, we can use the geo-replication. Or use multi-region architecture. So that is very advanced question. So when you architect your application in Azure, so you can use multi-region architecture option. So where it's just similar to, we can say, geo-replication, but little bit different. Your Azure VM suddenly stops responding. What will you check first? So by chance, something happened and your VM suddenly stops responding. So what will you check first? So first we'll go to the Azure VM health status. So in the health status, we'll check what happened. If we did not found any kind of proper, we can say, reason of that, so we can go for resource health monitor. If we do not get anything of that, so we can go for NSG rules. So we'll check whether your VM is breaking any NSG rule. That's why it's stopped or blocked somewhere. Now we also check the CPU memory uses. So there might be the possibility that your VM is consuming 100% CPU or memory. That's why it's not responding. Now Azure monitor logs. So we go to the Azure monitor and there we can check the logs. There we check the log. Now your company wants high availability for an application. What other feature will you use? Your company wants high availability for an application. So what other feature will you use? So the first preferred option is availability zones. Second, we can implement load balancer with multiple instances of application or multiple VMs. Traffic manager, which will help you to coordinate the traffic. Multiple instances of application. So we need this ways by which we can improve the availability of your application. Now your application suddenly receives very high traffic. So what other feature helps automatically scale resources? So auto scaling. So auto scaling is available and auto scaling will help you to scale the resources automatically when your application receives high traffic. Now auto scaling is available in app services, VM scale sets, container apps. So these are the four compute services we can use if you want to do the auto scaling. So when you would use Azure virtual machine instead of app services. Now to use VM when full OS control required. So VM is used when you want to have full control. You want to install, configure everything on your own. Custom software installations needed, or older applications, legacy applications. Custom networking required. So indirectly, if you want everything customized, so we'll go for the VM. But if you want to focus only on your application and you want all this to be managed by the other, so then we'll go for the app services. Now here, so legacy applications might be not supported in app services. So for that, you need VM. And that depends on the platform or technology used to develop that application, so the architecture of that particular application. Now, what is Azure App Service? Azure App Service is a PaaS platform to host web apps, APIs, and mobile backends. Benefits, what will get automatic scaling, built-in security, CI/CD integration, managed infrastructure. So CI/CD integration and managed infrastructure. Now, what is Azure Function? So Azure Function is a serverless compute service that runs code in a response to events. So if you have a very small code that is supposed to execute it, we had already seen the example. For example, when you user register in your application, you want to send a welcome message to the user. So it's just a small code which generates the mail and send, and it's required only when you register, a new user registers. So that it doesn't need, we can say, dedicated Azure resources for its execution. And it's based on some trigger. So in that case, we'll use Azure functions. So three popular, many triggers are there. Many triggers are there. So we can say more than 30, 40 triggers are there. But the popular triggers are HTTP request, HTTP trigger, queue trigger, timer trigger. Now, when should you use Azure functions? Use Azure functions when event-driven workloads, short background jobs, APIs, and scheduled tasks. These are some common scenarios where we can use Azure functions with that. Now, what is the difference between the containers and virtual machines? So VM include the OS, container shares the OS. Container do not have, we can say host OS. So container will use the guest OS. That is the instance of the host OS. VM has the OS. Now, VM is heavy because everything is part of VM. You need to manage everything. Now, container is lightweight. So VM is slow startup and container is fast startup. So what Azure services support containers? So three services we have in Azure to deploy the containers. So one is Azure Container Instances, ACI, Azure Container Apps, ACA, Azure Kubernetes Services, AKS. So Azure Container Instances, Azure Container Apps, Azure Kubernetes Services, AKS. How to choose the right container service in Azure is a trade-off between the control and the simplicity. Difference between the ACI and AC and AKS. Now, there are the three Azure services which will help you to deploy the containers or implement the containers. Now, if the question is difference between ACI, ACA, and AKS. Now, the same question can be phrased in different words. So, how to choosing the right container service in Azure is a trade-off between the control and simplicity. So, how you decide the container for your application based on the control and simplicity. Now, the simplest is ACI, so Azure Container Instances, very simple. So, simple building blocks. So, ACI is the fastest and simplest way to run the container in Azure. Think of it as in containers as a service, cars. So you just need to deploy your application. You do not need to worry about anything. So you don't manage any servers and there is no orchestration, anything. So you do not need any kind of orchestration. You do not need any server, anything. Now, best for isolated short live tasks. If you have independent, we can say code or app to run and it's short loud for specific duration it is supposed to run, then we can use ACI. Scaling manual. So since it's a basic, we can say service. So scaling is manual. There is no built-in auto scaler of that. Orchestration, so none. So you manage each container individually. Cost pay per second for the exact CPU or memory you request. So cost pay per second for the exact CPU or memory you request. Scenario, so you have a Python script that needs to run for 10 minutes every night to process a CSV file and then shut down. This is the one real time, we can say, scenario. So ACI is the simplest option and no auto scaling, so manual scaling used for short lived or short duration tasks for them. Now, other container apps, so ACA. Now, other container app is also called as serverless microservices. Few people call it as in serverless microservices. So when we say serverless microservices, it's nothing but the Azure Container App, ACA. So serverless microservices is a platform. So ACA is built on top of the Kubernetes, but it hides all the complexity. So it is serverless PaaS designed specifically for microservices. It handles things like traffic splitting, scaling, and service discovery and automatically. So indirectly, we can say, so ACA abstract orchestration. So management. So it abstracts the management of your, you can say, container. So it will be managed automatically, internally by Kubernetes. It is built on top of Kubernetes. But it hides all the complexity. So it is serverless PaaS, platform as a service, designed specifically for microservices. Now, if your application has a microservices architecture, or if you are planning to deploy or implement microservices application in a container, then we use ACA, but preferred choice is AKS, Azure Kubernetes Services. It handles things like traffic splitting, scaling, and service discovery automatically. So little more automation than your ACI. It has inbuilt traffic splitting, scaling, service discovery. Now, best for modern microservices, APIs and event-driven apps of that. So scaling is automatic, so it can even scale to zero when there is no traffic, so you pay $0. Now orchestration. So orchestration managed for you, powered by KEDA or Dapper. So we'll have a look at this KEDA and Dapper and Kubernetes in course 2. So orchestration, you do not need to worry about the orchestration. So cost, consumption-based, pay for what you use. Scenario, so you are building a web shop with 10 different, we can say, microservices that need to talk to each other and scale up during the flash sale. Now, while answering this question, I will recommend you to do not use KEDA or Dapper words. If you use these words in answer, there might be the possibility that interviewer will start asking you about these two. So smart move is you don't use this KEDA and Dapper. You just say orchestration managed for you. So our orchestration is automatically managed. Fine. Now here, next service, what is your orchestration that we'll see? So next is AKS, Azure Kubernetes Service. The full control orchestrator AKS is managed Kubernetes offering. So Kubernetes is a built-in API which will help you to do the orchestration. And AKS implement Kubernetes internally. So it offers you the Kubernetes services, managed Kubernetes services. So Kubernetes internally will be managed by the Azure, but orchestrations and other things you need to manage it on your own. If you want more flexibility than your ACM. So here Azure manages the master nodes, so main nodes. For you, you have full access to the Kubernetes API. So you are responsible for the cluster configuration, networking policies, and node management. So best for large-scale complex enterprise application running high customization. Now, previously, if you look at here, so what it's saying, 10 different microservices that talk to each other. So we can use the ACA. But your application is enterprise application. It has hundreds of APIs and libraries and different components. And if they want to talk together to generate some meaning or generate some application on large scale, then we can use the AKS. So it will get you full access to Kubernetes API. And installation, or we can say configuration of your Kubernetes internally managed by the Azure. And Azure will also give you master nodes. Node is master node that we'll see, we can say when we go for Kubernetes with that. Now, best for large complex enterprise application requiring high customization, scaling, so highly configurable but requires more setup, horizontal pod autoscaler plus cluster autoscaler. So don't use this word, just say highly configurable but requires more setup. Orchestration, full Kubernetes capabilities available. So this Kubernetes API is fully available. Cost you pay for virtual machines that run in the cluster, regardless of whether they are full or empty. So you need to run a complex fintech application that requires specific security agents, demonstrate or custom networking, CNI, or Windows-based containers, and many things together. So in that case, we'll use the AKS. Now, similar to AKS, we have other services. Okay, what does orchestration actually do? So when you have 500 containers, when we are talking about, we can say, enterprise application. So it will have the many modules, many actors, many use cases, and there might be the possibility we segregate those use cases, or we can say actors, or whatever logical unit we can say, in small applications, and those small applications will have multiple microservices running. Then we can host those applications in multiple containers. So when you have 500 containers running a global app, so you cannot manually manage them. So managing them is challenging. So orchestration will automate this. So orchestration is an automation which will help you to manage many containers automatically. And for orchestration, we can use tools like Kubernetes. They will handle heavy lifting, provisioning and deployment, automatically deciding which physical server has enough room to host a new container. So it will provision the resources as per the availability on the server, and it will deploy the containers or the self-healing if container crashes or servers face the orchestration The orchestrator detects it and immediately restarts a new one to maintain the desired state. Scaling. If traffic spikes, like we can say Black Friday or Diwali sale or New Year's sale, the orchestrator automatically spins up more copies of your app. So you can say this is just, we can say, small agent which will do the work on behalf of you. Load balancing. It distributes incoming user requests evenly across all the healthy containers. So no single one is overwhelmed or overloaded. Updates and rollback. It allows you to update your app's code one container at a time. Rolling the updates also same. So if the new version has a bug, it automatically rolls back to the previous version. Now, when would you use the Azure container apps instead of Kubernetes? Use container apps when simple microservices, no Kubernetes management required, auto scaling needed, serverless containers. Now, what is Azure Virtual Network? We had heard about this. So VNet is a private network in Azure that allows resources to communicate securely. That's the internal network of Azure. What is subnet? Subnet divide your widget into smaller networks, logical networks, where we can create the resource grouping. What is network security group? NAG. The NAG controls the traffic using rule based on source IP, destination IP, port, and protocol. Allow HTTP port 80. So what is VNet pairing? So VNet pairing connects two virtual networks so they can communicate privately. Now one virtual network cannot overlap another. And if you want to communicate these two virtual networks with each other, so we use VNet pairing. What are the types of Azure storage? So blob storage, queue storage, table storage, file storage, and disk storage. When you use the blob storage are preferably used to store the files or unstructured data, images, videos, documents, backups, logs. The blob storage used for images, videos, documents, backups, and logs. So what is Azure Queue storage used for? So Azure Queue storage is a service used to store a large number of messages up to millions that can be accessed from anywhere in the world via authenticated calls using HTTP or HTTPS. Its primary purpose is asynchronous messaging. Its primary purpose is asynchronous messaging. It acts as a buffer between different parts of an application so they don't have to wait for each other to finish a task. Fine. Now, without queue, so what will happen? The user clicks and upload the website, starts processing heavy image. The user's browser spins for 30 seconds while the server works. If 1,000 people do it at once, your server crashes. With Azure Queue Storage, so what we can do, we can work asynchronously. So when we say asynchronously, so what it means? Step 1, the user uploads the photo, the website immediately puts a small message in the Azure queue saying, hey, process the photo, hash 405 with a vintage filter. The website instantly tell the user, got it, will mail you when it is done. The user happy because the site is fast. Now the background worker like Azure function pulls messages from the queue one by one and process the image at its own speed. If the worker gets overwhelmed, the message just sits safely in the queue until the worker catches up. So Azure queue storage is a service used to store large number of messages, up to millions that can be accessed from anywhere. Its primary purpose is asynchronous matching. It acts as a buffer between the different minds. So I had already told you this example. I think this got repeated. Now, why we should use the message queue? For decoupling, the front end doesn't need to know how the back end works. They only talk through the queue. Resilience, if your back end processing server crashes, the message aren't lost. They stay in queue until the server comes back online. Burst handling, it smooths out traffic spikes. You can handle 10,000 uploads in a minute without needing a massive server that stays on 24/7. Now, these are the reasons where we prefer this. So, what is Azure table storage? So, Azure table storage is highly scalable, cost effective, no SQL key value store. It is part of Azure storage account family alongside the blobs, files, and queues, and is designed for storing massive amounts of semi-structured data. In the 2026 Azure landscape, it remains the budget-friendly alternative to Azure Cosmos DB for simple NoSQL needs. So this year, this is the most, we can say, popular service for NoSQL needs. If your database is not in SQL, relational, then we can use the Azure table storage. How it works, logical layout. Unlike a SQL database with a fixed column, Azure table is schemaless. Each row can have different properties in columns. However, every entity must have three mandatory system properties. One is partition key used for physical grouping and scaling, row key, a unique ID within that partition, and timestamp managed by the Azure for version tracking with them. So, real world example, IoT sensor logging. Imagine you have 10,000 smart thermometers across the city. Every minute they send their current temperature to the cloud. The problem, you have millions of small data points. So SQL database would be too expensive and slow for this much write volume. Definitely, SQL will be very costly and it will be slow. So in that case, we can use this table storage solution. So partition key, sensor ID to group all the data from one thermometer together. Row key, timestamp to identify exactly when the reading happened. Custom properties, temperature, humidity, battery, whatever the parameters that you want to put it into that particular storage. The result, you can store years of data for pennies. So when you need to see the history for sensor A, Azure finds the partition immediately, making the lookup incredibly fast. Now, in interview, so there might be the possibility that you might need to compare table storage versus Cosmos DB. When you pay more for Cosmos DB instead of using table storage. So कब करना चाहिए? So you go through this particular table. So Azure table storage, ultra low pay per GB transaction. The Cosmos DB higher provision throughput. Latency fast, no guaranteed SLA. So that is one problem with the table storage. Guaranteed less than 10 minutes. Only on a partition plus row key, every property is indexed. Now, indexing is only on the partition key in the row key. Here in Cosmos DB, every property is indexed. Now, global reach, single region with GR's backup. Now, multi-region, active and active. logs, metadata backups, high traffic apps, global users. Indirectly, to answer that question, you can say if you have application with a high traffic and it is used by globally by multiple users, then we can prefer to go with the Cosmos DB. If we have the users from only one region or narrow down to specific, we can say part of a region. And if we want to store the log, metadata, backups, then we'll prefer the table storage time. Now you might came to know that why 2026 and 2025 many companies had used Azure table storage. It's more popular NoSQL option. So maximum companies with SaaS, software as a service, providing you cloud backups, whether it is your telecom companies, whether it is your messaging companies, they're providing you the cloud backup. So, and they prefer to store the backups in Azure table storage. And this cloud backup concept started just, we can say, 1 year back or 1.5 year back. It was not popular before it. So suddenly it spiked the demand of Azure table storage. So what is Azure SQL database? Azure SQL database is fully managed relational database service based on SQL Server. So you can say SQL Server installed in the cloud, managed by the Azure. So Microsoft manages the backups, patching, high availability. Now, what are Azure SQL deployment options? For the Azure SQL deployment options, so single database, elastic pool, SQL managed instance, SQL Server on VM. So these are deployment options in Azure SQL. You can deploy single database, or you can use the elastic pool, or you can use managed instance or SQL Server on VM. Now, what is elastic pool? So elastic pool allows multiple databases to share compute resources, reducing cost. The elastic pool allows multiple databases to share compute resources, reducing the cost of that. So what is Azure Cosmos DB? So Azure Cosmos DB is globally distributed NoSQL database service designed for high scalability. Now we had studied in detail, I think, why these questions you can go through the can say previous notes, you will get the option. Now what is RUs? So RUs called so request units per second. Represent the throughput capacity of the Cosmos DB. Higher RUs, higher performance. So it's unit of throughput in Cosmos DB. So you occupy higher RUs, your performance will be higher. Now, what is partition key? So partition key determines how data is distributed across the partition. So good partition key improves the performance and the scalability. Just before I told you, so sensor ID can be a partition key. Now, what tools are used to monitor Azure resources? Azure Monitor, Log Analytics, Advisor. So we had a word about this. This is very simple and easy question that you can go. What is Azure Advisor? So Azure Advisor provides recommendations to improve the performance, security, reliability, and cost optimization. So you just generate the, we can say suggestions. What regard it will do? So to improve the performance or for security related suggestions or reliability or cost optimization. Now, most of the people prefer to use the Azure Advisor to improve the performance or to optimize the cost. Now, what is RBAC? So we had word about this. So role-based access control. Role-based access control controls who can access resource and what action they can perform. So what is managed identity? Managed identity, the instance of identity created by the Azure internally to authenticate the one Azure service talking to another Azure service without storing the credentials. So Azure resource is talking to Azure service or one Azure service talks to another Azure service without storing any credential. How would you design a highly available web application in Azure? So we'll prefer to use the app service, Azure app service, load balancer, Azure SQL Geo replication, Azure CDN, content delivery network, Azure monitor. So these are the, we can say, choices that will do to create highly scalable, we can say, geo-distributed, geo-replicated application. So your application must store large video files which store will you use. So we'll always prefer to use the block storage because it is optimized for large structured data. Now your application needs very low latency globally. Which database would you choose? So Azure Cosmos DB because it supports global distribution, low latency, automatic replication. So automatic replication available and very less latency. So SLA is there with the Cosmos DB, less than 10 ms. So global distribution, globally distributed, automatic replication, low latency. How do you secure secrets like connection strings? So we'll use the Azure Key Vault. How will you deploy an ASP.NET Core application in Azure? So Azure App Services, we can use, or we can use Azure VM, Azure Container Apps, we can use Azure Kubernetes services. So you can deploy the ASP.NET Core applications to Azure. How would you migrate a SQL Server database from one premise on-premises to Azure? So we can use the tools like Azure Database Migration Service, Azure Migrate, Backup and Restore. So we had heard about these services already. How do you reduce the Azure cost? Now, ways to reduce the Azure cost is use reserve instances. Auto scale reserve instances will get you discount while purchasing the instances. Auto scale resources, so scaling will automatically reduce the cost because it will cut down the resource utilization when less load or less traffic or less uses. Delete unused resources, use cost management to optimize the cost. Or you can also use Azure Advisor to get the advisor regarding the cost. Now, then we'll go for a few more scenario-based questions. If client requires 99.99% availability for VM, so what is the minimum configuration required? A single VM with a premium SSD only offers 99.99% availability. That is again less. So it's 90, not 99. To reach 99.99%, you must deploy 2 or more VMs across different availability zones in the same region. So you need to deploy at least 2 or more VMs with premium SSD and in multiple availability zone in the same region. So that makes 99%, 99.99% availability for your VM. So can you move a resource group to another subscription? What are the limitations? Yes, you can move one resource group to another subscription. So most resources can be moved. However, both subscription must exist within the same Azure ID, AD, inter ID, tenant. Some specific resources like certain marketplace assets might not support the move and must be recreated. So marketplace, I don't think so. We are use any resource from marketplace. So the condition is same Azure inter ID. Then you can move the resource from one subscription to another subscription, but sorry, resources can be moved, but it should be in the same tenant. Now, when would you use Azure functions or Azure app services? So this is a very simple question. Use app functions for short-lived event-driven task. Example, processing an image upload where you want to pay only for execution time. Use app services for longer running web application or API that require consistent underlying server environment to them. Now, this is again very common question. So explain the noisy neighbor. problem in the cloud computing and how Azure mitigate it. Noisy neighbor. So it occurs when one tenant consumes excessive resources on the shared host, slowing other down. So other mitigated this using resource governance, hypervision, and offering isolated app service plans or dedicated hosts for users who need physical separation. Now, who is the noisy neighbor? The noisy neighbor is a tenant who consumes excessive resources on shared host. So in the previous session, we had about hub and spoke. So if we have the multiple tenant in one Microsoft Intra ID and they have some shared resources, and if suppose X tenant is consuming maximum resources, slowing down other, then that particular tenant X is called noisy neighbor. So how we can manage this particular problem in Azure? We can do it using resource governance, hypervisors, or offering isolated app service plans, or dedicated hosts for users who need physical separation. So this is the way that we can manage the noisy neighbor. Now, what is the difference between a public IP or private IP in Azure VM? So I had explained you, I think so. So the private IP is used for communication within the VNet or via VPN or express route. A public IP allows communication from internet by default. By default, VM do not need a public IP to access the internet. They use SNAT, but they need one to be reached from internet. Fine. Now, scenario. So your application is expressing high latency during the peak hours. So you have scaled the web app, but the performance isn't improving. Where do you look next? I would check the database performance, DTU, vCore utilization, and network latency. What is the question to your application experiencing high latency during the peak hours? And you have scaled the web app, but performance isn't improving. So where do you look next? Fine. Now it also happens. Suppose I have a server in Germany with the same configuration, and I have a server in Mumbai with the same configuration. Definitely, Mumbai server will generate high performance as compared to Germany because latency is very low. Even though Germany server has more configuration than the Mumbai server, so still the performance will be little bit slow because there is a issue of latency. Now to look out, where we can look out and where we can check. So I would check the database performance, DTU vCore utilization. So using DTU vCore utilization, you can find out what is happening in database. And second thing that will check for network latency. Now often the bottleneck is locking database or lack of caching layer like Azure Cache for Redis. So I do also check if the web app and database are in same region. Fine. Now the next thing that we are developer accidentally deleted a production SQL database. How do you recover it and how do you prevent this in the future? So I will use the point in time restore. So while creating the SQL database, it asks you this particular question. So we want to enable this point in time restore. Now it prevents this. I would apply a read only or cannot delete resource lock at the resource group or database level. Now to recover database, we use PITR. And to prevent accidental deletion of the production database, I will apply read only or cannot delete resource lock at the resource group or database level. Now you need to grant a third-party auditor access to your logs for 48 hours only. How do you do this securely? So we haven't discussed this service, but as an interview question, so you should know. So I would generate a shared access signature SaaS token for storage account containing the log, setting the expiry time to 48 hours and limiting the permission to read. So we can create a SaaS token, and in SaaS token we can put the expiry of 48 hours, and we also put the permission read only. And we associate this SaaS token to a storage account where the auditor can access the logs. So another scenario, your company wants to migrate a legacy app and that uses hard-coded IP addresses. How do you handle this in Azure? So I would assign a static private IP to the VM's network interface NIC within the VNet. This ensures that the IP remains the same even if the VM is stopped or deadlocked or deallocated. Sorry. So what are the IP addresses that we have with your legacy application? So we can put those IP address to VM's network interface as a private static IP address. So you have two VNets. Suppose next scenario that we have. So you have two VNets, East US and West US. So that need to be communicate. What are your options? The primary solution is global VNet peering. It's low latency and uses the Microsoft backbone network. Alternatively, you can also use the VPN gateway, VNet to VNet. Could be used, but it is slower and encrypted via the public internet. Now, what is energy? So energy, and can it be applied to gateway subnet? A network security group energy contains ACL, access control rules, to allow denied traffic. No, you should never apply an energy to gateway subnet. It can break the functionality of the VPN route express gateway. So energy is always applied to subnets. I'm not the gateways. So how does Azure front door differ from application gateway? The front door is global service, layer 7, that uses Anycast for global acceleration. So application gateway regional service, layer 7, typically used for load balancing within the single region. Now this is again very advanced question. I don't think so. They'll ask you. Now there are a few more questions of that. So what we'll do, we'll discuss those questions in the next session. There are many other questions of that. Now, meanwhile, if you have any question, you can put it into WhatsApp. I will include that question into this video file.